Here we've got an RLC circuit. The Emax is 125, the Imax is 3.2, and we know that the current leaves the generator, so we have a phase angle of 0.982. And we're asked to find the impedance and the resistance. So the first thing that we should probably do is set up the equation Emax equals Imax times Z. So we can divide the Imax on this side, get the figure for Z, and that would be the impedance right there. So it would be 125 divided by 3.2 gives us an impedance, Z, of 39.0625, and this would be ohms right there. Now, the key to impedance is that it's an expression like this: C equals the square root of R squared plus XL minus XC squared. So we can set those things equal to each other. So we'll say 39.0625 equals the square root of R squared plus XL minus XC. I can square both of these. So that would be like 1,525, something like that, 0.88 equals R squared plus XL minus XC squared. Now before we go any further, I'd like to say that we could take the tangent of this thing, and that would be equal to XL minus XC divided by R. It's another equation we can use here. So let's try to take the tangent of 0.982. So that gives us 1.5 is going to be equal to XL minus XC divided by R. Okay, so I'll put the R on this side. Now I know what XL minus XC equals, so I can plug this into here. And I'll say 1525.88 equals R squared plus, in parentheses, R times 1.5 squared. So I'll basically get, I can square both of these things. So I'll have like a R squared, and then there's like a 2.24 plus the R squared. And then here we go, 1528, something like that. So now we'll just add that up. So we'll add 1. So now I've got 3.24 R squared and 1525.88. We'll go and divide that by what we just had. So we figure out the resistance squared, and we'll square root that. We just basically figured out that R equals 21.7. Now for the next part, we're looking at inductive versus capacitive. In order to figure that out, we just need to refer back to the angle that we have. Well, simply put, if we have a positive phase angle, then it's mostly capacitive. And if we have a negative phase angle, it's mostly inductive. But the reason why is because if we look at our phase diagrams like this, and let's say we had their current right here, this is the current. Usually it would be voltage L over there and voltage C over here, so LIC. And we'll remember that this is a positive angle, so that would actually be this direction. I know it seems weird, but this is where the EMF is. So this is the EMF. And so therefore we had a positive angle. And the reason is because it starts from here. It starts from the generator, and then it goes this direction. This is the direction that you're going, positive towards the current. So now you can see that we're on this side, meaning that if you wanted to try to do the Pythagorean theorem situation, you would need more VC on this side in order to get a positive angle here. If that was a negative angle, this would be on the other side, and then you would have something this way, and then you'd need more L in order to get it this way. So that's why when we have a positive angle, we are capacitive.